tomorrow will be better. On the question on the board, we are given a series and we are asked to find the value of n for which the sum of the first n terms of this series will be greater than 20. Follow me here, friends. Solution here. The first thing is to check for the nature of our series. Is it a geometric progression or is it an arithmetic progression? Okay. For the geometric progression, we know that we have to have a common ratio. Okay, that's what proves that we have a geometric progression. Meanwhile, for an arithmetic progression, we have to check for the common difference. All right. So let's start with the common difference. For a common difference, this term minus the previous should be equal to this other term minus this. And when we do this, we realize that it doesn't match, all right? The two values won't match. But for the common ratio, we will have to divide this time around. We will do this term divided by the previous, which should equal this other term divided by this previous now. And after testing, we realize that it has a common ratio. Therefore, it's a geometric progression. That's how to prove that a progression is a geometric progression. Now, having proven that this is a geometric progression, the next thing we're going to be doing here is to write out the expression for the first n terms of a geometric progression. Sn is going to be equal to, we have a factor of 1 minus r to the power of n all over 1 minus r. So this is it here. And in this equation, we have that a is the first term, which in our case here is 1. And then r, which is a common ratio, is obtained by this term divided by this, and this term divided by this, which should also be the same as this term divided by this. Okay, and at the end, we have that it gives 1.1, all right? The only unknown here is n, okay? We have what the sum of all these n's should give, or must give. It should be greater than 20, but we don't have the value of n itself, okay? So let's get it. Let's substitute each of these terms in this equation. We'll have that a1 into 1 minus 1.1 raised to the power of n all over 1 minus 1.1. This should be greater than 20. This should be greater than 20. Be very careful at the level of simplifying this expression. Now, down here is going to boil down to 0.1, but be careful. We have 1 minus 1.1, so it will be a negative answer, okay? So this means, and then up here, 1 times whatever is up remains whatever is up. So I'm going to write it like this, to the power of n, all over negative of 0.1 is greater than 20. Now, I'm about to do a cross multiplication. For those of you who have issues with manipulating this inequality signs, you just have to consider them like an equality sign. You only get to pay more attention if there's a negative sign, either multiplying or dividing both sides, okay? You can comment under if you have a problem, a particular problem with this, and I'm going to get back to the session for you, okay? So at this point, to avoid carrying alongside the negative sign, what I'm going to do is I'll bring this negative sign up here, okay? Because you should know that a all over minus b is the same as minus b all over a, all right? This is a property which I'm about to use here, all right? So this negative sign is simply going to go up. So here I'm going to have that negative 1 minus 1.1 here to the power of n all over 0.1 should be greater than 20. Now I can cross multiply. And before I cross multiply, notice that when this negative comes up here and gets into this bracket, the order is going to change, okay? Because now we're going to have negative times positive 1, which is negative 1, and a negative times negative, which is a positive, dear friend. So you have to be careful here. So this means I'm going to have 1.1 to the power of n minus 1 is going to be greater than 0.1 times 20 is going to be simply 2, okay? So this is what I have at this point. Now, no need to say in order to isolate, because this is the target here. This is what I'm trying to isolate. 1.1 raised to the power of n. So I'm going to send negative 1 to the right side of the equation. And like I said, let us treat this inequality sign as though it were an equality sign, okay? So when this crosses this sign, it changes signs automatically, okay? So to the left, I'm going to be having 1.1 to the power of n is going to be greater than 2 plus 1, which is simply 3, okay? So now since I have 1.1 to the power of n is greater than 3, be careful not to say divide both sides by 1.1 because this 1.1 here and n are not factor related. They are not coefficient related. N here is an index, okay? So the only thing I can do here to bring down this n and make it a subject is by using the logarithm function, okay? So I'm going to introduce a natural log on both sides. So I will say taking ln on both sides, taking ln on both sides, I'm going to have ln of 1.1 to the power of n is greater than ln of 3. At this point, this n here comes here as a factor and becomes n. Ln of 1.1 is greater than ln of 3. Okay, I'm almost done. At this point, all I have to do is to divide both sides by this because at this point now, this ln here, this ln of 1.1 is a factor of n, or we can say n is a coefficient of this. So to isolate n, I can divide ln of 1.1 on both sides, okay? So n is going to be equal to ln of 3 divided by ln of 1.1. And if you punch correctly on your calculator, you're going to have that n is going to roughly be equal to 11.8 something, okay? But now since 11 is not a whole number because we are looking for n, no, sorry, not equal to, we have a greater than. It's an inequality sign here, okay? So since 11.8 is not a whole number, we are going to round it up to 12, which is the closest whole number. So n should be greater than 12. And what this means is, it is from the 13th term that the sum of the n terms will be greater than 20. And that is it. Simply because tomorrow will be better.